So in this problem, we're finding the values of V and I as labeled in the circuit, assuming that it's a silicon diode with VD naught equal to 0.7. Looking at the circuit, we have a diode facing upwards going from -3 to 3 volts with a resistor of 1 kilo ohms in between it. So to solve this circuit, we make the assumption that the diode is on, which means that the current flowing through the diode is greater than 0.
In this direction.
So in order to solve for this, we do a KVL equation going from the bottom to the top of the circuit, starting with -3 volts minus VD naught, which is the voltage assumed to be across the diode when it's on, plus the voltage across the resistor, which finally equals to 3 at the top node. And then after performing some algebra and solving for I, we get 6.7 milliamps. However, in our notation, we have it so that the current is equal to negative D current through the diode, which means that the actual current through the diode is negative 6.7 milliamps, which is less than 0, which contradicts the conditions for the diode to be on, which means that this diode is actually off.
Yep. So therefore, since the diode is actually off, we're going to redraw our diagram to this diagram, where we pretend that the diode is a break, and therefore V must be equal to 3 because there is a break, so there is no current going through. I equals 0 amps, and the voltage across the resistor is the 1k ohms times 0 current. Yeah. So the voltage across the resistor is 0. So the voltage at this node is also 3 volts. There we go. That was quick.